So a triangular prism, we can see from our drawing, is when you have a triangle and you have, like slices of it, so many of them that you stretch it out. So let me represent that in VR. What would be the easiest way to represent that? I guess with a ruler and a 3-dimensional drawing. I'll use wire. So first, I will need to make an 8x6. I'm going to copy the drawing in our example, although I haven't read it out loud yet, but it'll be like 8 inches there. That looks, we'll count that as 8 inches, and then 6 inches across. That feels like, right? And then this is, the face of the triangle here. And then it goes back 22 inches. So if I know that this line is 8 inches, I know it's going to go back like 3 times as far as that, which means I did not leave myself enough room. So actually, I'll just go this way. So like, see, that's like 1, 2. I don't know. That's close enough. We'll count that. And let me finish building my shape. Oops. And there we go. Not bad. That's pretty much how I pictured this would turn out. Slightly, gotta move this one. Okay, so this, let me shrink it smaller, is a triangular prism. If, again, if it was drawn perfectly. So this is what we're going to be able to find the volume of. The volume meaning how much space is inside of it. Okay, and we have that triangular prism. Did I make that paper small on accident? And they show it here. Okay, and I made the example. It's 8 inches tall, 6 inches wide, and then 22.5 inches long. And they say, what is the volume of the prism? The bases of this prism. This is probably in your way, huh? The bases of this prism are the right triangles at either end. Okay, so I guess they're considering the triangle to be the base, meaning, I guess if anything, you would consider it like this, right? They drew it this way, or they drew it like that compared to you guys, but they're saying it's the basis. So the bases of this prism are the right triangle at either end. So first find the area of one of the bases. So to find the area of one of the bases, it's a triangle. Okay, so it's 8 inches and 6 inches, and we practice this, which is to say, to find the area of it, it's 1/2 of the base times the height. So 1/2 of 6 times 8, and you get that the area of just the triangle is 24. Okay, but that's an area, and we're looking for volume. Okay, so now when we have volume, we have a third dimension, a third variable that we are multiplying it times. So the area of a triangular base is 24 square inches. We got that. Next, use the formula V equals BH, where B is 24 and H is 22 and a fourth. So they're like, now that you know the formula of the base, this triangle, which we agreed was, what is it, 24? 24, square inches. Now that we have that, to find the volume of the whole prism, we just multiply it times the third dimension, in this case, we'll call this the length of it. Okay, 22 and a fourth. And here's how they say, they call it the height, which I guess makes sense because they said if the triangle down here is the base. So they're multiplying just the area of this triangle times the height. And the height, they told us, is 22 and a fourth inch. Okay. So when you multiply those two together, volume equals base times height. You get 24 times 22 and a fourth to get 534. So the volume of this triangular prism is 534 cubic inches. So all that means, so what is a cubic inch? I guess that actually seems like a really important mini lesson I should go into. A cubic inch is, whatever, like this is, if this is 22 inches, right? A cubic inch would be 1 inch by 1 inch by 1 inch. Like you'd make a little cube. Okay, that is 1 inch on every, like a little die, right? This is a cube. That's like 1 inch all around. Okay, and if this isn't, I don't think this is to scale, actually. I don't think 22 of these would have to be the same height as this, so I guess I can shrink it. Okay, so let's say that's a square cube. So what is 534, cubic inches or inches cubed? It means that there's 500. Oh, I should have made it a different color. But there's 500 of these cubes inside this shape. That if you like that's the amount of volume. That's how many would fit in here. How many cubes of inches? Okay, a 1 by 1 by 1 cube. Okay, so that's what that represents. Okay. Next, how do I know that the right triangles are the bases of the prism? Well, how do we know? Because, I mean, we can visibly see it. I guess a good hint, and I'm not sure what they're looking for here, is that they have identical shapes on opposite sides. That's what would make it a. That's one indication that we could call it the base, right? See how this triangle down here is identical, to the triangle up here? That's what we'd be looking for in a base, okay, of a triangular prism like this. I mean, it's also called a triangular prism, and that's the only triangles. But even if it wasn't the case, I'd say the fact that they are, I guess the fact that if I took this shape and I sliced it, right? One thing that I could consistently slice it with is these, see this red triangle I made up here kind of sloppily? I could slice this shape over and over into a bunch of red triangles. So that means it's a good base because it's something that I could kind of measure the number of times I could slice the shape. Versus, let's say I picked a different face. Let's say like I didn't know, how they told me the triangle? If I didn't realize that triangle was the answer and I tried like, like this base over here, this side, I'm like, maybe this is the base. I'll find the volume of, or I'll find the area of this green rectangle. I'm not sure if you guys are seeing that. Okay, so if I found like just the area of this green rectangle, what would happen if I tried to slice? Let me see if I can grab just the green. 1, 2, 3, 4. Good. What would happen as I sliced up my rectangle? Or sorry, what would happen as I sliced up this triangular prism? Well, we would notice that the first slice would fit exactly right, but then later slices of identical, because remember, we're like, oh, this is my base, this is what I'm slicing it into, wouldn't fit because, as you can see, oh, I can't grab you with that hand. Okay, I'm going to slice it, and I'll show you why it doesn't work. So I'm like, oh, slice, slice, slice. I picked the wrong base because I don't know what I'm doing, right? But then you can see, hopefully that translates. It's hard for me to picture what that would look like. That, parts of the green start bleeding, like start going over the edge. Parts of this green slicing goes over the edge because that wasn't the base. Because, like we can visibly see that the shape is changing as it moves down, okay? Hopefully that didn't make you more confused, but if it did, stick with me. Yeah, we're going to practice it a lot. Volume. So that's how I know the right triangles are the base. Again, because they're the one shape that's like you could consistently slice it. Or I think another good indication is that, it's identical shapes on both sides. So again, this green, the green triangle, it didn't work because if I went to the other side, there isn't a perfect rectangle, like parallel to it. So that's maybe another indication. Okay, 2. Describe the faces of the prism that are not bases. How are they alike? How are they different? And this is one of those lessons about reading the full problem before you begin, I guess. So what I notice before, let's see here. So they're asking, what about the faces of the prism that are not the bases? So that would be these bases, where did I leave my triangular prism? Oh, I drew all over it. Can I pick it out? Oh, I can just undo everything until there's only the triangular prism left. Click, click, click. Let's just undo everything. Click, click, click. How far do you think it'll let me go back in time? Like, is it tracking every single? Like right now? Okay, well, it worked, huh? That's crazy. That was lucky. So looking at this triangular prism, right? So let's describe the other faces. So there's this face over here. What shape is that face? Let me trace it to make it more apparent, although I kind of did the same thing earlier. This face is a, what shape is this? Oh, that's, there we go. What shape is this green thing? It's a rectangle, right? So one shape, or one of the other faces of the prism would be a rectangle. And then let's grab the shape again and see what we see. So let's rotate it. What about this face? What shape is that? What just happened? What about, this feels like the first lesson that the gimmick of VR is being more work than it's worth. Ironically, because I thought it'd be great in volume. So what about this face? This face is also a rectangle, and I'll outline it in different colors so you can see what I'm talking about. This face meaning like here to up here to up here. So the red is a triangle, or is a rectangle. And what do you guys predict the last face of this prism is going to be? Well, probably a rectangle, right? Because the other two, and we'll make this one like yellow so you can see it easily. This face over here, the yellow face, right? That's also clearly a rectangle. So how are they alike? They're all rectangles. How are they different? They all have different dimensions, right? Except for, you know what dimension they share? They all share the same length, I guess, and they all have different heights, right? So look at yellow again, and then see how it is the same, like this width, I guess, is what you could call that. But compared to green, different height, like the up and down is what's different. And in fact, red is like the really, again, like the same width as the other two rectangles, but a vastly different height. That's like the tall side. Now let's keep going. That's what I'd read for 2. 3. A second prism has dimensions that are 1/2 of the dimensions of the prism in the example. Kate says that the volume of the smaller prism is 1/2 of the volume of the prism in the example. Do you agree? Ooh. So do you agree that if I have each of the dimensions of my shape, would that have the volume? Well, we, or at least me in VR, can plainly see, no, it wouldn't. And here's why, right? If I wanted to have the volume of this shape, what would I do? I would cut it in half, right? Like what's the volume of this big, triangular prism? If I want to like have it, I'm cutting, I would just be like this. I would just cut like a huge, is that gonna work? A huge disc. I'd like slide this disc down. Bam. Okay, so now, just like that, you can see on each half of my cut, right? On each half of it is half the volume. Okay, but did I have every dimension to do that? No, I only have, which dimension did I have? I actually only have just the height of the prism, right? Like the original bases, these triangles, I didn't change their dimensions at all. It's still the same, base and height of this right triangle. Okay, so there you go. That's the answer. It's like no, because if you have the height alone, you would have the volume of the full prism. But if you have the height and you have the base, like having the base would mean, and how the base again was like the right triangle on the edge. Having that would be like literally shrinking it by half, right? And we can clearly see that this small shape, is not going to be half the volume of this larger shape. If I also am cutting, I'm also changing the height by half too. Cool. Okay, so let's do number 4.